Good morning, happy Monday or Tuesday, depending on when you're watching this. Today we're going to be going over section 1.4, which is solving absolute value equations. And it starts on page 17 in your guys' student journal. So make sure you have this and something to write with handy, because here we go. Before we get started with this chapter, this unit, there's a couple words to go through. Or phrases of words. The first one being an absolute value equation. This is really fancy and it seems like it, but it's not. All it means is it's an equation with an absolute value. And feel free to pause it here before moving on to the next definition so you have it written down. So an extraneous solution. This is a solution that must be rejected, or an apparent solution that must be rejected because it does not satisfy the equation. Again, feel free to pause it here to make sure that you get this all written down. So like I said, 1.4, starting on page 17 in your book, here we go. So today's goal is, how can you solve an absolute value equation? So we're going to consider the equation x plus 2 equals 3. So when we're solving this, there's two possible ways to get to 3. There's the way that we actually get a positive 3, and then there's a way that we get the negative 3. Because we know the absolute value of positive and negative 3 is just 3. So the two equations that we're going to be dealing with on this is going to be x plus 2 equals 3. And then the second one is going to be x plus 2 equals negative 3. Because it doesn't matter what happens when we take the absolute value of these two numbers, we're going to get a positive 3, which is the goal. And so now we're going to use those two equations and we're going to find the solution. So we're going to do this algebraically. So we have x plus 2. Actually, we're just going to use that same equation. So I'm going to subtract 2 from both sides. And I get x equals negative 5. So that's our first solution. And then the second one, I'm going to subtract 2 from both sides. And I get x equals 1. Hi, Callie. This is Callie. Sorry if she's distracting. We get x equals 1. And that's our second solution. And so now the main point behind this is, how can we use linear equations to solve an absolute value equation? We do this by setting our equations equal to the positive and negative form of that number. So feel free to pause this here if you need to get this written down. So next we're going to say we have a number line. Our goal is to take our number line and find the point in which x plus 2 equals 0. Well, I know the only way to get 2 equal to 0 is add its inverse or add its opposite, which would be -2, which is right here. And then it said in part B, we're going to go from -2 and we're going to go 3 points away in both directions. So I'm going to go 1, 2, and 3. And I end up at +1. And I'm going to go 1, 2, and 3. And I end up at -5. What do you notice about these numbers? I notice that they're the same answers that we got in part 1. And so to find our answer from on a number line is we have to start at whatever is being altered within the equation and then move based off of our answer. So I found the opposite of what was inside, which was that -2. And then I went 3 away because that was my answer. And I ended up at the same point. Alrighty, the last way that we're going to go through is using a table or using a spreadsheet. So I'm just going to take my number. So I have -5, -5 plus 2. That gives me -3, and the absolute value of that is 3. So I'm going to put my answer in there. You can pause it here and then check back to see if you get the same answers for the rest of the table. So if you're just joining us back, you can automatically tell that we still got our same answers that we did before for our x value to get 3. Yeah, x equals -5 and x equals 1. And so using the spreadsheet just kind of helps lay things out and can help you see the movement of our numbers based off of our equation. So how can you solve an absolute value equation? There's so many different ways. You can do it graphically, you can do it numerically, or you can do it algebraically. Whichever way you prefer is definitely the way that you can choose to use. It's totally up to you. And so be prepared to answer this question here in class today. What do you like or dislike about the algebraic, the graphical, and numerical methods for solving an absolute value equation? And give your reason. So I really want you guys to think about this question and determine which way you like and prefer for yourself. There is no right or wrong answer because it's based on preference. So here are some core concepts to think about when we are dealing with absolute values. The absolute value is always going to be bigger than 0. We're never going to get something that is negative. So that means if you're taking the absolute value of the number, it's always going to be 0 or positive. If you're taking the absolute value of a negative number, the absolute value is exactly the same as the positive number. It does not matter because the absolute value is measuring the distance a number is from 0, and distance can't be negative. The third one, when you have A times B and then you take the absolute value of it, it doesn't matter if you do the absolute value of each of those numbers first or last. Because of the properties of multiplication, you can multiply in any order. It remains the same with positive and negatives and dealing with absolute value. And then the last one to make note of is when you have fractions. So again, it's the same thing. If you take the absolute value before or after, it doesn't matter. But the big thing is B cannot be equal to 0, or the denominator, the bottom side of your fraction. If it is, then your answer is invalid because you can't have 0 on the bottom side of your fraction. And so we will do some extra practice problems later. So be prepared for those. And with that being said, make sure you get all of your notes done and we'll see you in class. Have a great day, guys.